Okay, so we're looking at midterm 2, number 3. If we look at A, we've got I think we did one like this a couple weeks ago in class. So, like I was telling Austin, when you have a product, you should probably be thinking integration by parts. And this would be a good candidate for that. So if I'm looking at this situation, we have this is kind of a rule of thumb for which one to pick for U and which one to pick for dV. So that's inverse trig, logs, algebra, trig, and exponents. Algebra would be polynomials. Okay. So in this case, we've got trig algebra, so it looks like this is going to be our U. So we've got U is x, then du is dx. And we've got then dv to be our cosine x dx. And so the antiderivative of cosine is sine. And then we're there. Okay. So now we use, this is when we have u dv is equal to uv minus the integral of v du. So then we just plug in our pieces. This was our original, so equals x sine x minus the integral of sine x dx. Yes?
Sorry, was the isolate for selecting V or U?
Selecting U. So this is, this is for your U candidates. So whichever one's higher, that's your candidate for U. I'm not saying that it's always going to work. I'm just saying that that's a rule of thumb that I found on Wikipedia. So generally pretty good. All right, so we're here. We have x sine x, then minus the antiderivative of this, which I believe is negative cosine. So that makes that positive, cosine x. And then since this is an indefinite integral, put a plus c. Those steps make sense? Okay. So let's look at the second one that maybe is more complicated. I don't know. So we have, again, indefinite integral. We have this situation here. 1 plus 2x cubed dx. Squared. Thanks. Squared. Okay. So this might be more complicated. Do we have any recommendations? If I made this u?
Yeah.
Okay. So I can maybe do a u substitution first. So 1 plus 2x squared. So if I do du, that gives me 6x squared dx.
It's 4. 1 plus 2x squared.
What? I'm sorry.
Mu is equal to 1 plus 2x squared.
Oh man, I'm awesome at that. Yeah, I just really want it to be cubed. Okay, it's also squared. So for x. Okay.
And then you're going to make x squared equal to u.
Okay. I'm sorry.
So once you put that into simplified, you're gonna be left with like an x squared. So you can make an x squared
Okay.
equal that.
Good. Okay, so great. So let's put in what we have now. So we've got the square root of u, that's that part, right? And then this takes care of part of this, and this. So when I put in a dx, I'll move it over here, sorry, a du, I've dealt with 4 of this, so I have 2 left over and I have x squared left over. So I have 2 x squared left over. Right? I can't leave it here because I really need everything to be in terms of u. So then I need to figure out some way to make x squared and what did you say?
So you use what you have for u equals 1 plus 2x
Great.
squared. And you solve for x squared.
Good, so we can solve for x squared here. So I subtract 1 and I divide by 2 and that gives me x squared. And the 2 is fine, that can come out, that's constant. And then instead of x squared, now I have u minus 1 over 2. Okay. Now this can be taken out as well, so that'd be 1/2, so those are gone. And I have u to the 1/2 times u, so that's u to the 3/2, minus u to the 1/2 times 1, so u to the 1/2. And I'm there. Okay. And then from there, the steps are pretty straightforward. I'm just adding 1, so 5/2, and dividing by 5/2, or multiplying by the reciprocal. And same thing here. I add 1, get 3/2, divide by the reciprocal, or sorry, multiply by the reciprocal, so I get 2/3, I have a plus c. And then, because this is an indefinite integral, I have to substitute back in. So I have 2/5, 1 plus 2 5/2, and then minus 2/3, 1 plus 2x squared, 3/2. Honestly, I don't think this.
He doesn't have it simplified on the
I don't think this would simplify very easily. So it'd probably just be a waste of time. Maybe if you had extra time at the end of the exam, go ahead and do that. But otherwise, I just leave it. All right. Number 4. Yes, sir.
How did you get the 3/2 raised to 3/2 1/2?
Great. So I was here. This half, I could pull that out here and it'd be 1/2, right? And then times 2, so those cancel. And here I have, so this would be square root of u times u minus 1. This is u to the 1/2 times u to the 1. So 1 plus 1/2, 3/2, and then same thing, same idea there. All right. Number 4, we've got integral from 0 to pi of sine t dt. Okay. Now for this one, he used a u substitution, right? And used cosine as the substitution. I don't know that I would have found that originally, so I might have used u as sine and tried it out and seen what happened. But basically, we're going through a simplification process. In this particular problem, we have 2 things going on, this to the 5th. So we're trying to use some trig identities and stuff. So he uses u equals cosine t, I believe, right? So that makes du is that a negative sign? Like that? So one thing that we can do here is if I put in,
Actually, we're trying to
Yeah.
figure out a U and it's not something that's in
Yeah.
the
okay,
function.
so let's do this. Let's see what happens if we put in sine t. So if we put in sine t, we get cosine t dt, and so the problem is here, I would have u to the fifth du over, or something like that. And then I'd have to figure out a way to get rid of that cosine t, right? Does that make sense? So the way he gets around this is, since this is raised to a higher power, he's using this idea that we have cosine squared t plus sine squared t equals 1, right? And so if he can do this, if we can find a sine squared t, then we can just say sine squared t is equal to 1 minus cosine squared t, right? So that's where he uses this fact that it's raised to a higher power to say, well, when I'm doing my derivatives, these go back and forth. So if I can somehow connect these sines to cosines, then I'll be in good shape. Does that make sense? So yeah, I'd say the first step would be, oh, I'd try sine. That doesn't work for me, and I say, okay, what if I try cosine? Because they're kind of related in some way. And so this is not like plug and chug math. This is more like doing substitutions. It's more art, right? You kind of get a feel for things, and as you get used to it, you get better at it. Okay. So let's try cosine t negative sine t dt. So if I put in this now, if I put in du, I'm replacing a negative and replacing one of these signs, right? So that leaves me with the fourth, like that, du. Does that make sense? I took care of one of the signs with this du, and so now I'm at this situation. The other thing to remember is that I can do that. So now I use this idea that I have sine squared, so I have 1 minus cosine squared t squared du, right, using that trig identity. And now I know that that's minus u, so I have 1 minus u squared squared du. And now I can do the exact same. I also, so I don't have to substitute back later, I can go from 0 to pi here, putting in 0, cosine of 0 is 1, I think. And cosine of pi is negative 1. And I should have left those negatives. So these were negative. That negative came out here because of this original thing. So I had a negative here. So I had a negative here. So now what I'm going to do is switch my bounds, make that positive, and switch my bounds to be negative 1 to 1. That process, I went a little fast, so is that okay? I had a negative that came out of this. brought it down. This was from 1 to -1, but it was negative, so I switched it and made it positive, and now I'm here. Does that make sense? Okay, so now I can actually just multiply that out. That might be the easiest thing to do. And say that's 1 minus 2u squared plus u to the 4th du. And then I won't finish this just to save some time because, we're doing this sort of thing, right? We're just raising it to a power, dividing, and then plugging in these pieces. When I save, I'm going to save 4b for a little bit so that we might be able to do it. Yes?
So when you have a negative on the outside, how did you can just flip the bounds because you took away that negative?
Exactly. So if you remember, when you're going from a smaller value,
Yeah,
they're
flipped. It's
they're the change. Yeah, exactly. So if I change the sign, then I also need to correspondingly change the bound. All right, so let me switch down to 6 real quick.
Why does it change from 0 to pi into 1 to -1 for the bounds?
Okay, because I'm integrating with respect to u, and here I was integrating with respect to t, and so my bounds in t were from 0 to pi, but when I put them into u, I put in 0, I get 1,
Okay.
I put in pi here, I get -1. Okay, so number 6 says find the volume generated when the area bounded by, okay, so in general we have y equals x cubed. We're looking at x equals 2. Right there. X equals 2. And the x-axis, that's here, so I don't need that anymore. Okay. And then we're doing 2 different things. One, we're rotating by the y-axis. The other, we're rotating by y equals -1, which is parallel to the x-axis. So in one case, I'm going this way. The other, I'm going down here. So in the first case, what I'm getting essentially I'm getting a big cylinder tub of ice cream, right? And I'm scooping out most of it. And I want to find out what's left over, right? How much ice cream I have left over. So that's this process. When I'm going around my y-axis, I think you're most familiar with the washer method. That's the one I would choose here. I'm taking a slice across here. If I take that slice, I'm cutting here, now I'm going to lay it out. It looks like a washer. Okay? The outside radius here is always the same. It's always the distance from here to this line, which is from 0 to 2. So that's always 2. Right? The distance here to the inside changes. Here there's no radius. Up here, it's equal to 2, right? So this inside radius is a function. And basically, we can see from here to here that that's the value x. But I don't want to leave it as x because I'm integrating, I'm doing a bunch of these washers, stacking them up here. So my thickness is in the dy direction. Okay? So in the dy direction for this one, I'm starting at 0, and I'm going up to this intersection point in the y value. So this is 2, 8, right? If I put a 2 in here, from here, I get an 8. So from 0 to 8, I'm stacking these washers up. my outside function is always 2, and I'm subtracting off this inside function, which is x, but I want it in terms of y. So I have to figure out if y equals x cubed, then x must equal cube root of y, right? So what I really want is the cube root of y. Okay, and that's going to get that value. Now when I'm going around, when I have this shape, and I'm going around, it was -1, is that right? Y equals -1. And you should try this with different numbers, like -2, whatever. So going around here, so in this case I have this shape, and I've drilled a hole through the middle, right? I've drilled a cylinder through the middle, and I want to figure out what's left. It's a very different shape from this. Right? In this case, I'm slicing this way, and these are my washers. In this case, I'm going from 0 again, but I'm only going out to 2. That's where it ends, at 2. So from 0 to 2. Here my outer bound is variable, right? It changes. My inner bound doesn't change, and it's always the distance from the axis that I'm revolving around to the x-axis, which is 1. So I'm always subtracting. Oh, I'm so. I didn't finish this. Sorry, guys. Shortcut it. Sorry. These are not just. These were the functions. Those functions are the radii, and the radii need to be multiplied. That's much better. Okay, sorry. So you get the radii. The radii have to be made into circles. So you have to square them and multiply by pi. Same thing here. I have 1 for a radius. I multiply by pi, I square it. And again, I'm going in the x direction, so that's my dx. And then this function here. The distance between here and here, well, that's my y equals x cubed. But I have this extra bit to get to the center, right, which is 1. So I actually have x cubed plus 1 as my radius. And then I square that and multiply by pi. So these are going to give you 2 different values, theoretically. I mean, they might serendipitously be the same, but these are different shapes, so you shouldn't expect them to be the same. So notice that I changed this value based off of how far extra it was from my equation. Any question over that process? I apologize again for the confusion there. Yes, ma'am.
When you have it like rotated over the line x equals negative one, x equals negative 1, that's a reflection over the y-axis, right?
So this is x equals 0, x equals -1, like that. So yeah, it'd be.